Welcome to a fantastic edition of Comet Algebra. This video is for Algebra 1, Chapter 13, Section 1, Rational Expressions. A rational expression is simply a fraction with polynomials. It's defined to be a ratio of polynomials, but we have to clarify that the denominator can never be zero. So rational expressions are just fractions, and you have been dealing with rational expressions since like third grade, but we just didn't call them that. 3/4 is a rational expression. X over x plus 2, another example. X minus 4 over 5, these are all rational expressions. So it's just a fraction with polynomials. Now there's something that is very important to get straight right from the beginning. We have to be able to find excluded values. These rational expressions might not exist everywhere. In fact, they do not exist where any number would make the denominator equal to 0. And we need to be able to find these excluded values. Some rational expressions don't have an excluded value. Let's look at 3/4, for instance. Is there any number that would make that denominator 0? And the answer is no, the denominator is 4. So this one has no excluded values. Now let's look at x over x plus 2. If x was equal to a -2, this denominator would be 0. Therefore, x cannot be equal to -2. -2 would be an excluded value. This rational expression has no excluded values. The 5 is the denominator, and there's no x that I could put in that numerator there that would make the denominator 0. Here, this excluded value, x could not be -9. Because of this squared here in this example, this one doesn't have an excluded value. And to find the excluded values in this one is going to take a little work, and it's going to involve factoring. So I hope all your skills from chapter 10, I believe, was factoring. I hope those skills are ready to go because we're going to do a ton of factoring in chapter 13. These first three examples just ask us to determine the excluded value or values for each expression, because sometimes there's more than one excluded value. So I'm going to do the math that you probably would just do this mentally, but what you're actually doing is taking this denominator and you're setting it equal to 0 to see what values of x would make that happen. And if I solve for this, I'd get 9. Therefore, x cannot be equal to 9 because that would make this denominator 0. Again, you probably could have done that just by looking at it. In example 2, we can't tell by looking at it. We have some work to do. Looking at this denominator and thinking about what you know of factoring, we need to factor this into two binomials. That will make it much, much easier to find the excluded values. So if you're thinking about the diamond, we want to find two factors that multiply to 7x squared and add to -8x. And that, of course, would be 7x and 1x, and they would both have to be negative. Therefore, I can factor this into, I'm going to write the entire fraction here just to be very clear. So here's my numerator. And the denominator factors into x minus 7, x minus 1. I'm doing a quick check, foiling, yep, it's good. So therefore, the two values that are excluded for this one, this piece, what makes this piece 0? Well, again, I'll just kind of try to be obvious. What makes x minus 7 equal to 0? Well, when x is 7. Therefore, that's one excluded value. X cannot be 7. And the other, if x was a 1, that would make this 0. So this one has two excluded values. X cannot be 7, and x cannot be 1. So example 3 is very similar. Let's go ahead and factor this denominator. And maybe you can do this mentally. What's two numbers that multiply to 32 but add to 12? And I'm seeing that 8 times 4 is 32, and 8x plus 4x is 12x, so I did factor this correctly. And then asking yourself what makes this term 0. X minus 8 would be 0 when x is equal to negative 8. Therefore, it cannot be negative 8. And then ask yourself what makes this binomial 0. Well, when x would equal to negative 4. So x cannot be negative 4. So once again, this rational expression has two excluded values. Now we need to look at the skill of simplifying these rational expressions. So you're going to be asked to remember what you know back from the exponent chapter. You're going to need to know all the things we learned in factoring, plus canceling. We got to review our canceling skills. So this example 4, we have 4a to the third over 8a. Well, this 4/8 reduces the way it always has since you were in whatever, 4th or 5th grade. 4/8 reduces to 1/2. So the 4, I don't need to write a 1, but you can. And the 8 would reduce down to a 2. So we've, in other words, we've taken a 4 out of here and gotten 1, a 4 out of there and gotten 2. This a divides away one of these a's, so we're left with an a squared. So completely simplified, example 4 is a squared over 2. Now example 5, we have to reduce the 180 over 27. We have to take care of the m's and take care of the n's, and you always need to ask yourself how many are left and where are they located, in the numerator or denominator. 9 goes into both 180 and 27. 9 goes into 180 20 times. 9 goes into 27 3 times. So I have a 20 for my number on the numerator. This m takes out one of these, so it becomes m squared. This n takes out one of these, so I'm left with 3n in the denominator. Number 6, we have the number 3 times a factor x minus 6 over a factor x minus 6. Now remember, only factors can be canceled. You either cancel the entire binomial or you leave it alone. So this entire x minus 6 divides out this entire x minus 6, and we are left with 3. Likewise, in example 7, we can only cancel factors. So this factor of 4 divides away this factor of 4, and we're left with x minus 1. Oftentimes, we have a little work to do before we can cancel. So a lot of times you'll hear me say in class, factor and then cancel. In example 8, we have a GCF in the numerator of 3, so we need to factor out the 3 and get an x plus 2. And then we notice that our denominator is 3, so these 3's divide away, and we are left with x plus 2 as the simplified answer. Number 9, clearly we have some factoring to do. These two terms in the numerator have a GCF of 9 and x. So let's factor that out. And I would get x minus 5. The denominator is 3x. Again, you can only cancel factors. So this x divides away this x. 3 goes into 9 3 times, so the final simplified answer is 3 times x minus 5. These last 3 examples definitely fall under the category of factor first and then cancel. So the numerator here, ask yourself what multiplies to positive 6 but adds to negative 5, and that would be x minus 3, x minus 2. In the denominator, ask yourself what multiplies to negative 2 and adds to a negative 1. That would be x minus 2 and x plus 1. And again, FOIL to check to make sure you factored correctly. So now I can cancel some binomials. This x minus 2 cancels with this x minus 2. And my final simplified answer is x minus 3 over x plus 1. Now let's look at problem 11. This definitely is also factor and then cancel. When I look at the GCF of the numerator, they both have an x and they both have a y squared. So I need to factor that out of both terms. This first term is xy squared, would just leave me a 1. The x would factor out and the x squared would just leave me a y. And the denominator is xy. So this x divides away this x. This y divides away one of these. So the simplified answer is y times 1 minus y. And the directions are typically going to say that we leave our answers in factored form. All right, last example. Again, factoring top and bottom this time. This numerator factors into x plus 2, x plus 2. This bottom, this denominator, is the difference of two perfect squares, x plus 2 and x minus 2. And the x plus 2's cancel out, and so we are simply left with x plus 2 over x minus 2 as our simplified answer in factored form. All right, now you have the knowledge you need for section 13.1, so have fun with math.